Hey, 5th and 7th period, it's Mr. Gabay. I had to be at a class today for some required training, but I wanted you all to get the benefit of a chemistry teacher for your notes. So your sub is going to kind of stop and start this video to give you guys time to write things down, and I'm going to go through the notes today. By the way, I miss y'all, and I'm looking forward to seeing y'all soon. Before I forget, actually, oh, that's weird. Before I forget, I'm having a contest. If you look up on the board up there, you'll see that I have some goals for the holidays. I'm trying to get some supplies for y'all to have, pencils, Band-Aids, Kleenex, things like that. And if I get 10 boxes of pencils, 4 boxes of Kleenex, and 2 boxes of Band-Aids, during finals week, I've got a Cosmo student who's ready to straighten my hair every day of that week. I've also had some requests from students like wearing skinny jeans and other weird things like that. So if I get those goals met up there, I will be dressing weird during finals week. That having been said, let's go ahead and take a look at the notes. First thing I want you to write down is the difference between covalent and ionic compounds. Notice that ionic compounds have brackets around the ions and charges up here, whereas the nonmetals do not. So make sure you have written down in your notes, ionic is a metal and a nonmetal, and covalent is 2 nonmetals. Okay, at this point the sub should stop the video for a second and make sure you have a chance to write those things down. Alright, we'll go ahead and move on. Next up, you guys have seen the octet rule before. It says that elements that have full valence shells are going to become more stable. What I want you to know about covalent compounds in the octet rule is they get their octet a little bit differently. Covalent compounds, instead of transferring from the metal to the nonmetal, they're going to share their electrons between them. In this picture here, you can see we've got 2 fluorine atoms, each of which has 7 valence electrons, so they're 1 shy of their octet. And so they're sharing these electrons, these 7th unpaired electrons in the middle. So if you count those, 1, 2, 3, 4, 5, 6, 7, 8, each of these fluorines now has an octet by sharing. So make sure in your notes you have written down that ionic compounds transfer electrons for their octet, whereas covalent compounds share their electrons for their octet. So you should have those words share and covalent, share and transfer. So ionic compounds transfer electrons, covalent ones share them. And I should probably start over, but this is like right before lunch and I don't have time to restart this video, so thank you for understanding. The sub will go ahead and pause for a second and give you a chance to write those down. Another way of seeing that would be with these 2 hydrogens. They each have an unpaired electron, so they can kind of share those between them to get, for hydrogen, 2 electrons. Remember, hydrogen is an exception to the octet rule. It only needs 2 electrons to fill that first orbital. Alright, when covalent compounds form, to get that octet, sometimes, like we saw in the last slide, they'll form a single bond. If that doesn't get them to their octet, they'll share more electrons and form a double bond. And if that doesn't work, they'll share even more electrons and form a triple bond. So in your notes, I need you to write down single, double, and triple bond. You may want to draw these pictures, at least on the top row here, to help you remember what those look like. And you should also write down that single bonds tend to be long and weak, so those atoms are far apart and easily ripped apart from each other. Whereas you add more and more shared electrons, those atoms become closer together, and it's harder to rip them apart. Those are stronger bonds. Okay? Notice that in a single bond, 2 electrons are being shared. Double bond has 4 electrons being shared. And in the triple bond, we have 6 electrons being shared. You can also see below different ways of drawing that. Sometimes the sharing electrons, the bonded pair, these 2 electrons can be shown as a line. So 2 electrons become 1 line, 4 electrons become 2 lines, and 6 electrons become 3 lines. So each line represents a pair of electrons. Okay, again, please make sure you have written down single, double, and triple bond. You may want to have pictures of each, but you definitely want to write down that single bonds are long and weak, triple bonds, as you go in that direction, sharing more electrons, they are shorter and stronger. Again, the sub will pause the video for a moment to let you copy those down. All right, so this part is for my on-level chemistry, my regular classes, as opposed to the pre-AP. So if this is the pre-AP class, if this is 5th period, go ahead and skip the video ahead a little bit. You've got some different problems. For my regular class, we're going to go ahead and work an example here, carbon tetrachloride. During the video, I want you to write down the example problem. And if you want a little bit later, you'll have time to copy down these 3 steps here that tell you how to work the problem. All right, so first thing, we're starting with carbon tetrachloride. So we're going to ignore the tetra for a second. That's carbon and chloride. So we've got C and Cl. Step 1 says to put the first atom in the center with the others around. So that means we're going to have a carbon in the middle with a chlorine around it. Now this tetra here is a prefix. We'll learn about those after Christmas. But tetra means 4, so we have 4 chlorines. So the formula for this would be CCl4. So that tells me I'm going to have to put 4 chlorines. Oops, that middle one is supposed to be a carbon, excuse me. Put 4 chlorines around that central carbon. Okay, so on your notes, please make sure you've written down CCl4. And you're starting to draw this picture with me here. Okay, this is what your next quiz is going to look like. A lot of drawing dot structures for covalent compounds. Okay, so it says to add the valence electrons next. So carbon is going to start with 4 valence electrons, and each chlorine is going to start with 7 valence electrons. Notice that for the chlorines, I've got those valence electrons facing the carbon. Having the unpaired electrons facing each other will make this a little bit easier. Okay, remember the number of electrons, like 7 for chlorine and 4 for carbon, comes from the top of your periodic table. So just go to the top of that group and find the number next to the A. Okay. Step 2 says share electrons until everyone gets to 8, gets their octet, or 2 electrons for hydrogen. And we're going to use a line to show every 2 electrons shared. So in this case, chlorine only has 7 electrons, so we're going to share those unpaired electrons with carbon by connecting those 2 dots with a line. And then I'm going to go ahead and do the same thing for each carbon and chlorine. Make sure you connect those lines carefully from dot to dot. And now that line is going to represent those 2 dots, and it's showing us that those 2 electrons are now shared between those 2 atoms. Okay, finally, step 3, check that each atom has 8 valence electrons, or 2 for hydrogen, and make sure it's neat. So what I like to do for that is, on my rough draft of my work, I like to kind of circle each of these and count up their valence electrons. Okay, remember those shared electrons will count for both neighbors. Okay, so we count those lines for chlorine, and then we'll count them again for the carbon. So looking at any of these chlorines, I can see 1, 2, 3, 4, 5, 6 valence electrons plus 7, 8 from the shared electrons. So each of the chlorines has 8 valence electrons. Carbon has 4 bonds around it, each of which is a pair of electrons. So that's 1, 2, 3, 4, 5, 6, 7, 8 electrons. So carbon has 8 electrons as well. On your quizzes, you guys are going to have a separate box to put your final answer so you can make sure it's neat. Neatness is really important because if I can't tell where your dots and your lines are, you won't be able to get full credit for that. So I'm going to go ahead and redraw it here. If you've got it drawn once in your notes, that's fine. As long as you have that finished dot structure in there, these examples are going to help you out when you're doing some practice afterwards. Okay. So at this point, the sub can pause the video if you need a chance to get that written down. And I'm going to go ahead and move on to the next problem. All right, next up, we've got a new compound. We've got a new compound, phosphorus trifluoride. Okay, so again, see, I do dumb things even when I pre-record. All right, so phosphorus is going to be a P, and trifluoride, tri like a tricycle has 3 wheels, means 3, so trifluoride tells me I need 3 fluorines, so I'm going to put 3 F's around it. Remember, step 1 says that the first element in your formula goes in the middle. Okay, so make sure in your notes you write down, now we're doing PF3, and go ahead and do your framework. Phosphorus in the middle with 3 fluorines around it. Okay? Then again, we need to add our valence electrons in. So that's going to be 7 for each fluorine. And again, make sure you're putting those unpaired electrons facing the center so they can make those bonds. I'm going to do the same thing for the 5 electrons of phosphorus. I'm going to put those 3 unpaired electrons facing the fluorines. Okay, step 2, share electrons until everyone gets up to 8. Use a line to show the 2 electrons shared. So again, I'm just connecting those lines from fluorine to phosphorus. Like that. And now I can check, before I do my final answer, does everyone have their octet for step 3? So again, I like to circle them. If you want to do it in your head, that's fine. So the fluorines, just like chlorine in the last problem, has 6 electrons to themselves and 2 electrons that are shared for a total of 8. Meanwhile, on the bottom, phosphorus has 2 electrons to itself and 3 bonds. So that's 1, 2, 3, 4, 5, 6, 7, 8. Phosphorus has its octet as well. And I'm ready to neatly draw my final answer. Again, make sure you show me clearly where all the dots are. Because if I can't tell where they are, or you connect your lines weirdly so it looks like there's an extra electron floating around, you might lose some points on that, so be careful. Okay. That's our last problem, so at this point, for the regular class, you can go ahead and stop the video, and there's a practice sheet for you to try these out on. And then if you're my pre-AP class, start here, I guess. So, yeah. Okay, all right, so bye, 7th period. I'll see you later. Take care. All right, so starting from 5th period. All right, let me erase this problem. Was from on-level chemistry. All right, pre-AP. Hopefully you skipped over those first couple problems because we're going to find a different way to work those problems that's going to help you out when we get to the harder problems. So I'm going to work 1 easier problem and then 2 tougher problems. Please, please, please make sure you write these problems down in your notebook. If you don't have those written down, the practice is going to be really hard and it's going to make things really tough when I see y'all next week because I would hate to have y'all kind of picking this up with me at the last minute and not have time for retakes if you need them. So please make sure you're taking good notes while I'm gone. Alright, so let's go ahead and start with carbon tetrachloride. I've got 2 elements in here. I've got carbon, obviously, which is C, and I've got tetrachloride. So let's just ignore that tetra for a second. That's chloride, Cl. Tetra is a prefix that means 4. So that tells me I have 4 chlorides. Don't worry too much about the tetra. We're going to learn about the naming a little bit later on. I'm going to basically start you out with the formula, CCl4. So let's go ahead and make sure you write that in your notebook, CCl4, and then follow along and write the formula as we go through here. Okay? Now, the first step says to put the first atom in the center with the others around it. So the first atom in our formula is carbon. So we're going to go ahead and put a C in the middle and surround it by the 4 chlorines. All right. Now, based on that, we can now go ahead and figure out how many total valence electrons we have available. Okay, so in this case, I have 4 chlorines, each of which I know has 7 valence electrons. So 4 times 7 gives me 28, plus 4 more from the carbon gives me 32. So I'm going to write on the side here that I have 32 electrons to kind of spend to get everyone their octet. I really recommend that you write these counts along with me because this is going to be a key part of our strategy for writing these formulas. Okay? Step 2 says put bonds in. Okay, so let's go ahead and do that next. We're going to go ahead and connect all the chlorines to that central carbon. And we need to adjust our electron count now because we spent some doing that. we said that each line represents a pair of shared electrons. So 2 shared electrons. That's 1, 2, 3, 4, 5, 6, 7, 8 electrons total. Which means out of that 32, we subtract the 8, and we only have 24 electrons left. Next up, we need to satisfy the terminal atoms, then the central atom. The central atom means the one in the middle. In this case, carbon is our central atom, and the chlorines on the outside are our terminal atoms. Okay, so first let's satisfy the terminal atoms. They each already have 2 electrons from that bonding pair, so we're going to add 6 more electrons to get them 8 total for their octet. And we're going to do that for each chlorine. Okay, and that was 6 times 4. I spent 24 more electrons, so I'm going to subtract that out. And I'm left with 0. I don't have any electrons left over. Okay, so take a second. The sub can pause the video while you make sure you have this much written down. And now I'm going to go back and make sure everyone has their octet. So looking here for for chlorine on the left side, I see 1, 2, 3, 4, 5, 6 electrons to itself, and then 7, 8 electrons in that bonding pair. And it's the same for every chlorine, so all of these seem to have an octet. For carbon in the middle, I see 1, 2, 3, 4, 5, 6, 7, 8 electrons just from those bonding pairs. So it's got an octet as well. And we're ready to go ahead and draw our final answer here over in the side. Okay, so I'm going to have a box on your quizzes for you to draw your final answer, because a lot of times you'll be erasing or crossing things out if you're working in pen. So you have a box to make sure your final answer is really neat. If you're not neat, then I might think you don't understand where the electrons are supposed to be, and you might lose some points even if you get it. So make sure that final answer is really neat. And again, if needed, the sub can stop here and make sure you have that copied down in your notes. Actually, okay, so I'm going to leave this up here. One thing I recommend is that you copy down these 3 steps at the top, because those will help you out a lot. So have the sub stop for a second, and let's go over and copy these 3 down into our notes. If you're running out of room, just try and bleed on to another page. Alright, so hopefully you've got those steps written down, you've got that first example problem written down. We're going to go ahead and move on to some of the tougher problems here. One kind of challenging problem you're going to see is going to include polyatomic ions. So the polyatomic ions are what we saw before in the ionic unit. These are groups of atoms all sharing a charge, like sulfate, for instance, SO4. Those atoms are all bonded together covalently, but because they have a charge, they can then form an ionic bond to another compound. So drawing these is going to help get us a better picture of how some common ionic compounds are put together. Okay, first thing you want to do for sulfate is look up what is the formula for sulfate. If you open your star chart, your formula chart, you'll see that it's SO4 with a 2- charge. Just like before, we're going to put that first atom as our center atom, as our central atom, so sulfur, and then the oxygens are going to go around that for our terminal atoms. Okay, and I need to start by doing my electron count. Okay, each of these is going to have 6 electrons. 6 times 5 tells me I'm starting with 30 electrons this time. What's different about a polyatomic ion is that it's got a charge. So if you have a 2- charge, you've gained 2 electrons. That tells you you have 2 extra electrons to spend here to get everyone to their octet. So go ahead and add those in. So we have 32 electrons to spend here. 32 electrons. Again, please make sure you're writing down this example problem with me, and make sure you're keeping this count on the side. Okay? We have to connect all of our atoms. That's step 2. So 1, 2, 3, 4 bonds. Since each of these is 2, that counts for 8 electrons. We can subtract that out, and we're down to 24 electrons again, which will give us enough to satisfy the terminal atoms. So we'll put 6 valence electrons on each oxygen. Okay, and that takes out our last 24 electrons, leaving us with 0. And if you check, everyone has their octet here. Now, like you saw in the beginning of the notes, ionic compounds have brackets and charges around them. So let's go ahead and add those brackets and add that 2- charge to the top. Now this could go on and bond with a metal because it's got a negative charge. So this covalently bonded polyatomic ion can now form an ionic bond. Again, the sub will pause the video here so you can make sure you have our example problem written down. Make sure you write that this is SO4 2-, the actual picture of the dot structure, and this little electron count here, because that's going to help you out when we're working our problems. All right, and last but not least, you'll have problems that have what's called resonance. So let me try and demonstrate that for you. For this case, it says draw the dot structure for nitrate. Again, it ends in H or ite. You know, that's a polyatomic ion. So you look it up and find that that's NO3 with a 1- charge on it. Okay, so we'll start off with nitrogen in the middle. We draw our 3 oxygens. And by the way, if you're drawing this in your notebook, please make sure you kind of start and leave yourself some room to the left and the right, because this problem is going to kind of expand across. It's going to take a lot of space. Okay, so we start off the same way. Let's figure out how many electrons we have. 6 from each oxygen is 18, plus 5 from nitrogen is 23, plus 1 more, because it has a 1- charge, is going to start us off with 24 electrons. So 23 plus the extra electron is 24 electrons. Okay, we draw our bonds in like before. That spends 6 more electrons and gets us to 18, which we can then use to put valence electrons on the terminal atoms and make sure they've got their octets. That's going to require 6 for each oxygen, which takes out all 18, and we're left with 0. The problem is that this nitrogen doesn't have its octet yet. It's only got 1, 2, 3, 4, 5, 6 electrons. So what I'm going to do is I'm going to take maybe 2 electrons from this top oxygen, erase them, and force him to share those 2 electrons with nitrogen, forming a double bond, which you remember is stronger and shorter than a single bond. Okay? And then of course, since this is an ionic compound, we would put brackets around it, along with that 1- charge. I should have left myself a little bit more space, but that's okay. Now what makes this what makes this problem a little bit tougher is that you have to recognize that even though I drew the double bond here with this top oxygen, I could have done the same thing with either of these left or right oxygens, and it would have still given you a dot structure that gives everyone an octet. So when that happens, you're going to end up drawing all 3 structures. So I'm going to have this up pause for just a second so you can get this first part down, and then I'm going to go ahead and add those 2 structures. Okay, and just so I have room, I'm going to go ahead and erase the count of electrons. So I'm going to need some space on the side. We're going to draw a double-headed arrow and essentially redraw the same structure with the double bond in a different position. Okay, and that would still have a 1- charge. So that's the right oxygen this time. And I have to draw a third structure because it could just as well be on the last dot structure. So actually, I'm sorry, those dots should not be there. All right, so I'm running out of room here, but let's go ahead and draw another double-headed arrow, and we'll draw our last dot structure on the side here, the nitrogen double bonding to the left oxygen. Again, I got to remember to keep that charge there and get all my unshared electrons drawn on. And we're all set. So this is called a resonance structure, because that double bond can kind of exist with any of these oxygens. It's kind of shared between all of the oxygens. Okay, so again, the sub is going to go ahead and pause the video here so you can get this down, and then you guys can start on your practice. Thank you guys so much, and I'm looking forward to seeing y'all next week. Take care.